Hi guys, it's your science teacher here with another video. This time I'm going to go through the whole of the topic of optical isomerism with you guys. So without further ado, let's get started. We get optical isomers when we have chiral molecules. And what it means to be chiral means that you have a non-superimposable image. Just think about your hands. If you have your left hand and your right hand and you try and place them on top of one another, that is an example of a non-superimposable image because they are exact mirror images of each other and they cannot be placed perfectly on top of one another. Now, this happens in molecules when we have four different atoms attached to a central carbon atom. Now, although these molecules do look the same, in fact, they are mirror images of one another, they could display different properties due to the fact they are optical isomers. Now, we can spot whether we have chiral centers by looking out for whether there are four different groups attached to a carbon. So let's look at some examples. Here I've drawn out bromobutane. Can you spot where the chiral center would be in this molecule? It would be in fact here, and we mark our chiral center using an asterisk. And if I was to draw out my two optical isomers and my mirror image, I would do it like this. I have my bromine atom on top. I usually have my hydrogen going away from me. I will say that I have my C2H5. Notice how I've put the carbon first. That's very important in these diagrams to make sure you put the carbon exactly next to the wedge. And I have my CH3 going away from me. Now, if I draw my mirror, I can draw my reflection on this side. One way examiners could try and trick you with a question like this is they will in fact put a symmetrical molecule in. So they might draw out bromopropane like this. And this is in fact a symmetrical molecule, so therefore there is no chiral center in this molecule. Also, molecules can have more than one chiral center. Check this molecule out that I've just drawn here. This in fact has one chiral center here, one here, one here, one here, and one here. So it has 5 chiral centers in total. The reason why the carbon here is not a chiral center is because of the fact that it has 2 hydrogens bonded here. So therefore it does not have 4 different groups attached. Now you might be wondering why it is important to know about optical isomers. Well, there was actually a really important incident that occurred when we didn't know too much about optical isomers, and that is the tragedy of the drug thalidomide. Now, thalidomide was a drug that was used to treat morning sickness. And it is a chiral molecule, as you can see from its chemical structure here. You'll notice that it has a chiral center just here, and there are two isomers. And the isomers are labeled R and S, but you do not need to know why they are labeled like this just for your A-level course, but you will do when you get to university. Now, as well as treating morning sickness, it also had terrible side effects, and it caused birth defects in young children that were born when pregnant women were taking the drug to cure their morning sickness. Now, the R isomer is the useful one. This is the one that had sedative powers and used to help cure morning sickness. However, the S isomer was incredibly dangerous as it was teratogenic, which means it could cause birth defects. Now you might say, well, why don't we only produce the R isomer and therefore we could just use thalidomide and roll it out? Well, the problem with that is the fact that when it gets inside of our body, it will interconvert between the two isomers to create what's called a racemic mixture. And a racemic mixture is basically when you have 50-50 of both isomers. And the isomers are known as enantiomers. That's another key term you need to know. Now, we need to be really careful when we do nucleophilic addition reactions because of the fact these are often reactions that will cause racemic mixtures. And the reason for that is because the nucleophile can add from either side of the double bond and attack from either side. Now, if it attacks from the top, then the CN will be my top group, whereas if it attacks from the bottom, that will be my bottom group. And I can just draw the rest of the optical isomer. Now, of course, racemic mixtures have both isomers in, and these isomers can behave differently. You can do tests to see whether you have a racemic mixture or only one of the enantiomers present. What you can do is you can shine plain polarized light at it. Now, light vibrates in all directions, so you can use a filter. And what will happen with this filter is it will polarize the light so it only shines in, vibrates in one direction. So this obviously is vibrating up and down. Now, if it goes through one enantiomer, it will rotate it clockwise and you'll get vibrations going like that. And if it rotates the other way and goes through another enantiomer, it will rotate it so it's going anti-clockwise. Now, if you've got a racemic mixture, then you will see that the plain polarized light will just vibrate and oscillate in that same direction as one of it's rotating the light clockwise, one of it anti-clockwise, and so the racemic mixture will cancel each other out. I hope you've enjoyed the video. Please remember, if you do like it, to drop the video a like and subscribe to the channel.